Hi, and welcome to our project called The Hill House. We are an international team of 3 students at the Copenhagen School of Design and Technology. In our elective course, we had the objective of developing a selected design brief. The design we chose to develop is a 100 square meter single-family house. The house is in accordance with the Danish building regulations. As a team, we chose a building system that is lightweight and consists of wooden studs and rafters, with a detached load-carrying steel column and beam system. To progress with our technical solutions, we tested how vertical and horizontal loads would affect our building. Our reasoning for the steel column and beam system was due to a potential of excess loads on the roof, and to accommodate the open floor plan with a non-bearing glass facade. For lateral loads like wind, the wood stud system serves as shear strength. We did not need to use bracing on the steel structure due to the building scale and wood stud system.
We will now show you a technical cross-section and take a look at the standard construction build-ups. First, the most prominent feature of this section, the folded roof. It is an extensive green roof on top of a cold roof construction. We decided to use 2 sets of battens on top of the rafters to allow cross-ventilation, because the architect's design did not include a ridge vent. The ceiling is made from alternating pine strips with a black, sound-dampening backdrop. For the external walls, we chose a Danish-style wooden stud construction with a total of 200 mm of insulation. The cladding is made with timber strips that were burned at the surfaces to shield it from the elements. Next, the substructure. We chose a strip foundation for lightweight and small buildings. It is made up of 2 lightweight aggregate blocks on top of reinforced concrete and has insulation on the inside to minimize the heat line loss. To prevent frost damage, the concrete is extending 900 mm below the ground level. For the slab, we decided to go with a standard 150 mm concrete slab to prevent rain and gas infiltration from the soil into the building. As the architectural finish, we chose a layer of polished screed with floor heating pipes. If we look at the south side, we can see the glazed facade. It is an aluminium mullion transom stick system with glazed panels and openable windows and doors to ensure natural ventilation and access to the exterior living spaces. Last but not least, we decided on a standard drywall construction on timber studs with a moisture membrane adjacent to the wet rooms for the internal walls. This key junction shows the upward sloping eave above the glazed facade on the south side. As this is the highest point of the roof, it is also the main ventilation opening at the cross-ventilating battens. The opening is protected by an insect net and an overhang of the green roof construction. To achieve the cladded overhang, we decided to install an extra rafter with a welded bracket to the steel beam. Battens are then attached to the rafter and the cladding strips are fastened to those battens. An extra piece of plywood holds the green roof construction in place, and an aluminium flashing closes the construction off.
Here we can see the north elevation roof eave. To allow adequate water flow to the drain, the soil with planting doesn't come to the edge of the roof. You can notice an inspection chamber made of galvanized and plastic-coated steel used for better drainage. This area is filled with gravel to achieve better access to the inspection chamber and to protect it from unwanted vegetation. To protect the cladding cavity from the rainwater, we decided to use aluminum flashing, which wraps around the eaves of the roof.
As a group, we discussed several solutions. One option for the substructure was a solid strip foundation. Instead, we used expanded clay blocks to save on costs and to reduce the amount of concrete used in our project. The reinforcement of concrete slabs and the strip foundation was determined by using the European design standard Eurocode 2. In the architectural brief, we also noticed that the base of the interior walls had a floating effect. To achieve this, a gap of 95 mm was made from the finished floor. Then an aluminum skirting finish is installed into this gap and is secured onto the OSB board.
The architect's concept for the design was to blend the house with the landscape. The concept embodies a simple and minimalistic design. The wooden cladding refers both to modern architecture and traditional Scandinavian houses. One of the main features of the house is a small hill behind the building. Thanks to that, the hill house refers to the landscape in a literal way. It also allowed to hide the yard behind the slope and make it more private. The hill, covered with flowers and herbs, becomes a bridge between the wild meadow and the building. This is a perfect way to respect the context of the location.